We're going to continue graphing quadratic functions today. This is just a little bit of a review of what we did yesterday to refresh your memory before you try some practice problems. So if you remember, we did graphing in both standard form and factored form. So standard form looks like this, where you have the ax squared plus bx plus c. And so remember, in these cases, this is where you do the x coordinate of your vertex equals opposite of b over 2a. You find the y-coordinate for your vertex, and then either you can use the y-intercept or a table of values to find some remaining points. So here with my equation, I have a negative x squared. So that tells me a is -1, b is the coefficient of x, so it's going to be a 5, and then c is -9. So when I go ahead and plug in, I have the opposite of b, so -5 over 2 times a, which is -1. So -5 over -2, that's going to be +5 halves. And so when you run into something like this, you may want to change it to a decimal. Typically in this class, we're not going to give decimal values, but this is really the same as saying 2.5 or 2.5. Just for graphing purposes, we want to have an idea as to where that's going to be. Y-coordinate of your vertex, if you're going to use a calculator, you can, or you can go through and do the math by hand, which I'll show you here in case you're interested. When you square a fraction, you square the numerator and the denominator. So this is going to be the opposite of 25 over 4 when we square the top and the bottom. Plus, here this is really a 5 over 1. When we multiply fractions, we go across the top and across the bottom. So that'll be 25 over 2 minus 9. Then we're going to need a common denominator in order to add or subtract these fractions. So this will be -25 over 4. And then here we need a denominator of 4. So we probably want to multiply by 2 over 2. So that'll be plus 50 over 4. And then here we're going to need something over 4. So this is a 9 over 1. So we're going to have to multiply by 4 over 4. So it'll be minus 36 over 4. And then when you're adding or subtracting fractions, that denominator stays the same. So then you just need to add or subtract those numerators. So what we have going on here, we've got -25 plus 50, so that's going to be 25. 25 minus 36 will be -11. And again, you probably want to convert that to a decimal value or at least a mixed number so you know where to graph it. So say we do a mixed number here. 4 goes into 11 twice, but then there's 3 left over. So that's going to be a -2 3/4 or a -2.75 if we have that decimal value. So for that vertex, we have an x value of 2.5. We have a y value of -2.75. We're just going to do our best to graph those about where they fall. So here's our 2.5. -2.75 is close to -3, but not quite there. Now, our y-intercept here is -9, which is off the graph. So kind of to put it way down here and then reflect it over might be a little too much of a stretch. So we can go ahead and make our t-chart. I'm going to put the vertex in the middle of 2.5. And then -2.75. So here, in order to find x values, I wouldn't necessarily jump to another decimal value because then it's going to get messy like we have over here trying to find y. I would pick a whole number x value. Maybe if I go back 1.5 units, now I'm at x equals 1. And then symmetry-wise, if I go up 1.5 units, then I'm at x equals 4. Those will be a little more reasonable and easier to plug in. So for the y-coordinate here, if I plug in a 1, here this is going to be 1 squared, which is 1. Oops, I lost my equals. So it's -1 plus 5 minus 9. So this will be 4 minus 9, which will be -5. So at 1, I'm at -5. And then again, it's symmetrical. So I could plug 4 in, or I could just reflect this over to get my remaining point. And then just a review of domain and range from yesterday. Domain is all real numbers. because that continues forever in the x direction. Our range, since it's opening down, is going to be y is less than or equal to the y coordinate of the vertex, which was the negative 2.75. Okay, so here is an example that we can actually graph this using the vertex form that we learned about in 2.1, or we can graph it using the intercept form that we learned about yesterday. So just to review from 2.1, we had y equals a times x minus h quantity squared plus k, where your vertex was located at that point hk. And so here, our vertex would be located at negative 2, 0. So we could plot that point at negative 2, 0, and then pick a couple others to finish our graph. If we use intercept form, just cross this off here. This is really saying 3, and then x plus 2 times x plus 2, because it's the x plus 2 quantity squared, so there's 2 of them. So here, the x-intercepts, we're going to take that factor of x plus 2 and set it equal to 0, which will give us x equals negative 2. And both of these are going to give us x equals negative 2. So that's this same point here. So in the case where that happens, we can't really find a halfway point between the x-intercepts because there's only one of them. So in this case, you're going to have to make a t-chart. And this value is also the vertex. So we can put that in the middle, because our graph's either going to start here and go this way if it only has one x-intercept, or start here and go this way if it only has one x-intercept. This one's going to open up because that a value is positive. So then we can just pick something on either side. So maybe we pick x equals negative 1 and x equals negative 3. Then we just plug those in, and again, we can still use symmetry. So if I plug in negative 1, negative 1 plus 2 is going to give me 1, and I square it. So I've got 3 times 1, which is 3, and then again, it's symmetrical, so I can reflect that over to the other side. So here's 1 point, reflecting it over, oops, and I get that parabola. Let's see if I can fix that a little bit here and erase that extra line. As far as domain and range goes, your domain is still going to be all real numbers. And then your range, we still look at that vertex. So here, we're starting at 0 and above. So y is greater than or equal to 0. Here's one more example of that intercept form from yesterday. This one we can't do in vertex form because the parentheses aren't the same. So we find our x-intercepts. And again, we do that by setting our parentheses equal to 0. So x minus 1 equals 0, x plus 1 equals 0. Here, if we add 1, we get x equals 1. Here, if we subtract 1, we get x equals negative 1. So here's 1 and negative 1. And hopefully we can see that in between them, our halfway point is going to be 0. But again, for your vertex, if you can't see that, we can always add them together and divide by 2. So 1 plus negative 1 divided by 2 gives us 0. But then we have to figure out how far up or down that point's going to be, so we need a y value. Again, that's the x coordinate for the vertex. So we plug that into the original equation. So 2, 0 minus 1, 0 plus 1. So that's 2 times negative 1 times positive 1, which will be negative 2 times 1, or negative 2. So our vertex is at 0, negative 2. So domain is all reals. Range is y is above, so y is greater than or equal to negative 2. Your homework for today is similar to what you had yesterday. The 22 to 30 evens is going to be in standard form, and then the 54 to 60 evens will be in factored form.